So here's a primer video for how much electricity this stuff use. So this will explain the series that you will watch here, one time, so that as you see the results or hear the results, you'll kind of understand the context and be able to figure out, does it make any sense to you or make a difference to you. So really, I was always curious about how much electricity stuff use around the house. Does it matter? People always say, well, you shouldn't plug this in or plug that in, or conserve electricity here and there. So not meant to be super scientific, but I just wanted to kind of at least get an order of magnitude of, is it significant or not, and what are the costs of doing typical things with a device. Like, how much does it cost to make a cup of coffee? How much does it cost to vacuum? Things like that. How much does it cost to run your refrigerator every day? And also, not only just to use it, but the other argument or issue going around is how much electricity things use turned off but still plugged in. And then they say, okay, well then you should unplug everything before you leave and whatever. Obviously you can't do all that, but what stuff makes a difference, what doesn't? They even make power strips now that automatically know when things are off, and so it cuts off power from the outlet to basically do that same thing for you. So apparently it's significant enough for them to sell products for that, which probably for entertainment systems and things that have a ton of electronics plugged into them. So anyway, I just wanted to go through a series of some things and kind of see the magnitude, what stuff makes a difference or not, and hopefully answer some questions. But also here I'm going to explain the electricity rates, which in itself I've learned a lot about, and it's not as easy as you might think. It's just not a rate times time, and that's it. There's, at least where I live, which is in Georgia, and I'm sure it's different everywhere, but it's a tiered system, and it's also seasonal. So, but anyway, I'll get into that in a second, but I want to show you this device I got, which I'll be using. You plug it into the wall, and then you plug whatever you have into it, and it's going to display here how much watts are currently being used, and the cost, which you can set, a time, duration. It tracks kilowatt hours, volts, amps, high and low of watt draw during a cycle. And here's where you can set your units per kilowatt hour. So whether it's 15 cents, which I have it set for, and I'll explain why, or $15 or whatever you want to put as per unit per kilowatt hour. And therefore, when you run a cycle and it tracks the time, it automatically calculates the associated cost with that kilowatt hour usage. So that being said, let's get into the rates. The rates here, I did a little sheet for where I live, again, Georgia. This is Georgia Power. Now this is kind of for your standard plan. There's a lot of plans out there, but I think most people are on the standard plan. They have flat rate plans, so obviously that wouldn't apply unless you have your rate. You can calculate it yourself. But anyway, what I'm trying to get to in these videos is how much power it uses, and then translate that into what is likely an estimate of the actual cost. So here's how it's set up so you understand going forward. And here we've got a tiered system, which is not only by usage, so that's kilowatt hours. Mine falls always in around the 400 something range, so I'm always what I call a low tier user. And then you have mid tier, so you get to the next level. It's like tax brackets, pay more or less. And then a high level user, and here are the associated rates. Now also, so that's one, and the is also seasonal. So in the summer, it's pretty good premium. It's actually the same base rate as the winter rates, but right as you get up past this first bracket, it jumps up. This is about 67%. It jumps up for a short amount, and then beyond that, it's 72% from the base. So again, depending on where you land in this number range, it's going to be a weighted average of these rates. So all I've done to make it simple is I've just qualified it as, I've called it a low range and a high range, because the jump from here to here is almost as great as a jump from here to here. So I'm basically putting these together for all intents and purposes. And I'm going to call it 70% because the weighted, it's going to be different for everybody. So when I say low, that's this rate, and when I say high, that's 70% greater than this. That's with the two numbers you're going to see everywhere, the low and the high. So it's that one and then that one plus 70%. Now, where's the differential breakout? So I wanted to figure out translating into dollars per month, because also it's not just the rate. Once you have the rate, you have all these variable fees and recovery fees and taxes and account fees, which, by the way, roughly estimated for me, even though this is my rate, cents per kilowatt hour, I end up paying effectively this, which is, I want to just round it to 15 because it's still a variable estimate. So anyway, it's almost about 3x what your base rate is, which I really didn't know. But anyway, that's what it is. So that's why I use the assumption of 15 cents per kilowatt hour for me for the low bracket users. So for the high bracket users, you would add 70% to that, which I think is like 26 or something like that. Anyway, but as far as you translate, if you want to do it the easy way, translate it into your bill per month. If your bill is less than $90 a month, you probably fall in the low bracket. If it's more than $90 a month, now you're in this high bracket. So in other words, if you're over $90 a month, you should worry about it, because all of a sudden you're paying 70% more for your electricity for every single thing you use. So it's going to make a bigger difference, much bigger difference there. So if you're in a big house or a house with a lot of people, it's going to start mattering a lot more when you get over $90 a month. So that's as best I can explain it. There's a lot of other things that go into it as for discounts and other things, but just humor me and we'll go with the low and the high, and we're going to get a guesstimate of how much stuff things use per minute, per hour, per day, per year, and per cycle, things like that. So just curiosity's sake. I hope you enjoy. Watch the video playlist and like, subscribe, comment, and suggest whatever you can. And by the way, obviously this can only plug into 120 volt items, so I can't plug in like stoves or washer dryers, things like that, heavy duty appliances, which are, big power hogs, but unfortunately can't do that. So thanks, and hope you enjoy. Bye.